Day 51 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. Day 51. I hope you guys had fun this weekend. I know I did. We had a little heat wave. I did some LeetCode. Then I went to the pool. Then I came back, did some more LeetCode. Then I woke up, did some LeetCode, and went to the pool again. And came back and did some more LeetCode, guys. But I hope you guys enjoyed yourself as well, because it's important to enjoy yourselves when you're trying to stay consistent and stay disciplined in other things, because that's going to help fight the burnout. If you try to do the same thing all day, if you're doing LeetCode all day, every day, you're most likely going to experience some type of burnout, guys. So it's important to enjoy yourself. You could go out, have some fun, and come back and do some more LeetCode. LeetCode's not going anywhere, and this page isn't going anywhere either. We'll both be right here when you get back. So go ahead and enjoy yourself. Have some of that you time, man, so you could come back and be focused when you're in LeetCode and not think when you're on this page and not thinking about some place you would rather be. It's no place I'd rather be than right here doing this LeetCode problem with y'all. So I hope you guys feel the same way. And if you don't, go enjoy yourself and have some fun and come back. We'll still be here doing LeetCode problems when you do. Just don't stay away too long, because you don't want to forget everything you learned. But yeah, with that being said, guys, you already know what I need you to do. I need you to take your mouse, 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 bring it right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash the like button for me, guys. And then after you smash that like button, go ahead and drop that bank emoji in the comments. I need all of my bankers out there to go ahead and drop a bank emoji in the comments, so we could grow this community, help this Swift community grow, help this channel grow, and bring Swift awareness to a greater amount of people in the world, so that we can all be Swifties out here. No Taylor Swift. We Swifties, no Taylor Swift though. And we can all code and learn LeetCode together. Get right with these data structures and algorithms. So let's see what question we have here today. Today we have question number 437, Path Sum 3. The difficulty level is medium, guys, but you already know we're not going to let that deter us. We're still going to keep the solution as simple and easy to understand as possible, because if you don't understand the solution, then you're not really learning anything. You need to understand these solutions and exactly what is happening, so that you can apply that same knowledge to another question when you get there, and when you have to answer another LeetCode problem, you'll already have a better understanding of what to do, because you understand the previous questions that you have done. And in order to do that, you need to understand the question. So let's get to it. It says, given the root of a binary tree and an integer target sum, return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at the root or a leaf, but it must go downwards, i.e. traveling only from parent nodes to child nodes. So let's look at example 1. Example 1, it gives us a root. It gives us an input, which is the root, which equals the tree, gives us a list of values in the tree. The target sum is 8. The output is 3. The explanation, the paths that sum up to 8 are shown. So let's look at the paths that add up to 8. So we have one path here, two paths, second path here, and the third path here. So 5 plus 3 equals 8. 5 plus 2 plus 1 equals 8, and negative 3 plus 11 equals 8. And they all follow these parameters that they gave us right here. The path does not need to start or end at the root or leaf, but it must go downwards, i.e. the traveling only from parent nodes to child nodes. So these three paths right here all follow these parameters, and they all equal the target sum, which is 8. Which is why the output is 3, because there are 3 ways to reach 8. So let's look at example 2. Example 2 is not as nice. It doesn't give us a tree, but it does give us the input and the root and the list of values in the tree right here. And the target sum is 22, and the output is 3. The output is 3 because out of this list of values, there are only 3 ways that can add up with these parameters to equal 22. So it's the same thing, just without the picture. So I hope that makes sense to you guys. So let's see how we're going to code that. First thing we're going to do, we're going to create a helper function. We're not going to get too fancy. We're just going to call that. We're just going to call it helper. Then we're going to have some parameters. It's going to have a node, which is going to be a tree node. It's going to have a sum, which is going to be an integer. And it's going to have a current sum, which is going to be an integer that equals 0. We're going to start it off at 0. Then we're going to come over here and we are going to say guard let node equal node, else we are going to return. Then we're going to come down here, we'll say let new sum equal current sum plus node.val. So that's just going to add the vowels up until it's going to add the value to the current sum, which is going to give us our new sum. And then we're going to come down here, we're going to say if new sum is equal to sum, then we're going to say count plus equal 1. And that's going to keep track of all the paths that equal the target sum. But remember, this is a helper function, and then we're just going to call it sum. Then we're going to come down here, we're going to say helper node.left, and it's sum, current sum. We'll set that as the new sum. Then we're going to come down here, we're going to do some more recursion, and we are going to say helper node. We're going to do the same thing for the right. Helper node sum, then we're going to say comma current sum. We're going to set that equal to the new sum. Then we're going to come up here. Oh guys, don't forget, forgot to declare the variable count. Count equals 0. So we're going to declare a variable called count, which is equal to 0. We're going to put that outside of both of these functions. That's where this count, because right here, count plus equals 1, we need to declare the variable 2. So right here, we're going to declare variable count equals 0. Then we're going to come up here and we're going to say guard let root equal root, else we are going to return 0. Then we're going to come down here, we're going to say helper. We're going to call the helper function by saying helper root, comma, target sum. Then we're going to come down here, we're going to do some more recursion. We're going to say path sum. Then we're going to say root.left, comma, target sum. And remember, this is the recursion, so path sum is coming from right here, path sum. That's where it's coming from. And we're going to do the same thing for the right side. We're going to say path sum, root.right, comma, target sum. And that's all she wrote, guys. So no, it's not all she wrote. We got one more thing, because we have to return the count. Say return count. Now that's all she wrote, guys. Now let's run it and see what happens, guys. Fingers crossed, and it's accepted. So let's submit it and see what happens when it's submitted. Let's see. There it is. Ooh, 161 milliseconds beats 12.67 users with Swift. Could be better, guys, but like I said, we're trying to keep the solution easy to understand, and I feel like you guys should be. This is beginner stuff, or it's easy to understand. And there it is. Until next time, guys, I'll see you guys then. Peace.